Hello my dear students, in this lecture we are going to understand swept volume flow rate. Now the swept volume is represented with Vs, right? It is represented with Vs, and the flow rate is nothing but per unit time. Therefore it is represented by Vs dot, and the unit is for swept volume unit is meter cube, and for rate it is per unit time, therefore meter cube per second. The unit of swept volume flow rate is meter cube per second. Now let us understand, let us say there is a piston cylinder assembly. Let us say this is a cylinder. Inside this cylinder the piston is reciprocating from two dead centers. This is the first dead center of piston, that is top dead center, and there is another dead center of piston, that is bottom dead center. This is a bottom dead center, and between these two dead centers piston is continuously reciprocating, right? Therefore this distance between top dead center and bottom dead center is called stroke, that is represented by L, where L is nothing but stroke, right? Or displacement of displacement of piston, right? By this much amount the piston is displaced inside the cylinder from TDC to BDC and BDC to TDC, right? And this cylinder will be having some diameter. Let us say the diameter of piston or diameter of cylinder is D, capital D, right? Therefore the swept volume here, the swept volume Vs is nothing but the volume displaced by the piston. It is also called displacement volume. It is swept volume or also called displacement volume. Displacement volume, that is actual volume displaced by the piston inside cylinder. Therefore this swept volume is nothing but pi by 4 d square. This is the area. Pi by 4 d square is the area of cylinder, and length is L, that is stroke into L. This is the swept volume for one cylinder in meter cube. This will be in meter cube for one cylinder, right? And let us say there are such x number of cylinders. Let us say x is number of cylinders. Now as one cylinder will sweep the volume of pi by 4 d square L, therefore for x cylinder the total swept volume for all the cylinder considering, let us say Vs, right? This is Vs for one cylinder, and here total swept volume is Vs, which is nothing but for one cylinder it is pi by 4 d square L, and there are such x cylinders, therefore we have to multiply with x. Therefore total swept volume is x into pi by 4 d square L, right? But my dear students, unit is meter cube. This is unit is meter cube, and our target is to find swept volume flow rate, that is meter cube per second, right? Now let us say En is RPM of this crank. En is RPM, revolution per minute, right? Now if I want to convert this revolution per minute, it is revolution per minute, and if I want to convert this revolution per minute, we have to divide with 60. Therefore N by 60 is nothing but revolution per second, right? Which is nothing but called hertz, that is revolution per second is nothing but hertz, right? Now let us understand the geometry of piston cylinder assembly. Let us say here there is a piston, sorry, this is a cylinder, and between top dead center, this is the top dead center TDC, and between bottom dead center the piston is reciprocating BDC, and distance between top dead center and bottom dead center is called stroke, that we have already seen here, right? Let us say the piston position is somewhere here in between top dead center and bottom dead center, right? And piston is connected to connecting rod. Here this is a connecting rod, right? This is a connecting rod, and connecting rod is connected to the crank. Let us say there is a crank, and crank is rotating. This is a crank, and this crank is continuously rotating, right, like this. Now can you understand here, if this crank position, if this crank position becomes vertical like this, then the the connecting rod will be also vertical, and the piston will be at TDC, top dead center. So let us draw this diagram. The top dead center position of the connecting rod, right? Let us say the piston is at top dead center like this, then this connecting rod will be vertical, and after connecting rod the crank will be also vertical like this, and crank is pivoted here, and the crank is rotating like this, right? Means the TDC position, top dead center position of the piston is top dead center position of the crank over here, right? Now, as the crank covers half rotation, let us say by rotating like this, crank comes to this location, that is bottom dead center of the crank. Then the piston will also come to the bottom dead center. Let us understand the bottom dead center position of the piston. For bottom dead center position, the crank is pivoting at this point. The crank will be like this. Let us say this is a crank now. This is your crank, right? And bottom dead center. And the connecting rod is connected with this end of crank. You can see this end is rotating and will come here. Therefore, connecting rod is coming down, and at this location, connecting rod will be like this. From this location, the connecting rod is like this, and up to this location, and piston will be at bottom dead center, right? And crank is rotating like this, right? Therefore, can I say when crank rotates from top dead center to bottom dead center, that is half rotation of crank is nothing but one stroke. That is, for half rotation of crank, the piston reciprocates between top dead center to bottom dead center. This is a stroke, right? This is called stroke, and the length is stroke length, right? So one thing we have understood, that half rotation means one stroke. Therefore, we can say one complete rotation is equal to two stroke. One complete rotation is equal to two stroke. And simultaneously, therefore, for k rotations, there will be 2k stroke. That you have to understand. Now we have seen for x cylinders, total swept volume is x into pi by 4 d square L, right? And n is rpm, therefore n by 60 is revolution per second, rps, revolution per second, that we have seen. Now number 1, two stroke engine. Let us say in examination it is mentioned that the engine is a two stroke engine. Two stroke engine means power is produced by two strokes. Power is produced, we can say power is produced by completing, after completing in two strokes. And my dear students, two stroke is nothing but one rotation of crank. That is one rotation means by complete rotation of crank, for complete one rotation of crank, power is generated. Therefore the swept volume flow rate, theoretical swept volume flow rate here, vs, is nothing but x into pi by 4 d square L. This is in meter cube. If I divide with second, that is into n by 60. This is in per second. 1 upon second, revolution per second. It will become meter cube per second. Therefore, swept volume flow rate is equal to x into pi by 4 d square L into n by 60. This is a swept volume flow rate in meter cube per second. Now that means for one complete rotation of crank, let us say this is a complete rotation of crank, there will be one power stroke, right? Now let us say this is a top dead center position, and there is a bottom dead center position. Now during this complete one rotation, there will be a suction. After suction, there will be a compression. In this one rotation only, there is a suction, there is a compression, as well as there is expansion is nothing but power stroke, therefore there is a power. And there is a exhaust, that is exhaust stroke, there is a exhaust also, right? Means for one rotation there is suction, compression, power, and exhaust. That is complete cycle. This is a complete cycle. As crank rotates by one rotation, then there will be a complete cycle, that is suction, compression, power, and exhaust, and power is generated, right? Now let us understand four stroke engine. For four stroke means power is generated after four strokes. Let us say second condition is four stroke engine. If they mention you four stroke engine, that means power after four stroke in four strokes. Single power is generated in four strokes. That means four stroke means two rotations of crank. Let us say this is the first rotation of crank. During first rotation, there will be a suction and there will be a compression. And for second rotation, there will be a for half portion there will be a power stroke, that is expansion, and for half time there is a exhaust stroke, right? And that means the 4 strokes are for 2 rotations of crank. That means for a cycle the complete power is generated after 2 rotation of crank. So we can say after one rotation there will be half power is generated. For 2 rotation full power means for 1 rotation half power. So this swept volume flow rate is equal to x into pi by 4 d square L, this is meter cube, into n by 60. Now for 1 rotation half power, therefore multiply with 1 by 2, therefore for 4 stroke engine swept volume flow rate is equal to 1 by 2 into x into pi by 4 d square L into n by 60. This is the swept volume flow rate. Similarly for k stroke engine, right? Likewise we can write for any number of stroke engine. We can write for 6 stroke engine, for k stroke engine, for n stroke engine, whatever may be the case. Let us say third case is k stroke engine. For k stroke, that means in k stroke power is generated. That means in k by 2 rotation, power is generated. Means for full power we need to rotate the crank by k by 2 times. That means in one rotation 2 by k power is generated. Therefore swept volume flow rate is equal to 2 by k into x into pi by 4 d square L, right, into n by 60. This is how we can calculate swept volume flow rate in meter cube per second. Similarly for 8 stroke means k is equal to 8. So swept volume flow rate is equal to 1 by 4, k is equal to 8, x into pi by 4 d square L into n by 60. Similarly if someone says 6 stroke engine, for 6 stroke k is equal to 6, 6 stroke engine means k is equal to 6. Therefore swept volume flow rate is equal to 2 by 6 is 1 by 3 into x into pi by 4 d square L into capital N by 60. This is how we can calculate the powers. Thank you dear students. In next lecture we will understand volumetric efficiency.